Thanks, Lita, for the introduction. So I'll jump right into talking about International Cancer Genome Consortium. For some of you, you may, in case you joined recently, you may not know about ICGC, but ICGC was started back in 2008. The first initiative was to catalog 25,000 tumor genomes along with matched normals. And so this is actually a portal that has already been set up, and so we can find the data there. We were close to 25,000. We had about 22,000 donors with genome sequencing data, and then another additional 2,000 to 3,000 that are with clinical data, but no molecular data to go with it. So this is a data set that has been used in a lot of publications, and you can still refer to it. The ICGC has finished in last year, so there's no more additional data coming in, but I'm sure the data will still be used by many groups. And then the second ICGC initiative was the pan-cancer analysis of whole genomes. You probably heard a lot about this recently, since it was a long effort. It was started in 2014, but the publications only came out in February of this year. So it was a very large effort involving more than 700 researchers. You can still go to the Nature website to find the collections of paper. Now, why did we do PCOG? Well, the reason is because in ICGC 25K, data submitters were sending us the mutation calls that they have done using their own analysis pipeline. So there's a large variation between calls that are not necessarily biological differences. There will be technical differences in the batches. And that's why in PCOG, we collected the raw sequencing data from the 2,800 patients, donors, and then we used a uniform analysis on these samples. So that means doing alignment and then doing mutation calling. We used 3 different pipelines to do mutation calling, because in the end we realized having 2 calls made out of 3 give us much more higher accuracy. So having learned that lesson, when ICGC starts its latest initiative, which is ARGO, Accelerating Research in Genomic Oncology, we are definitely collecting just raw sequencing data and doing this uniform analysis again. So the criteria to participate in ARGO is that there should be at least a whole genome or whole exome, or in some cases there may be an extended panel, and then plus the RNA-seq data. And as we have also learned, high quality clinical data is very important. So we will be setting a very high, strict bar for our submitters, that they must have a certain amount of clinical data to be part of the program. So far, we have 25 programs participating. They across 13 countries. They have committed just over 58,000 donors. As you can see on the map, these are programs in North America, Asia, and Europe. And we are just hoping to get more participation from other countries as well. So far we have over 220 individual tumor types, primarily with a high number in esophageal, colorectal, pancreatic, and gastric. And there's also some programs contributing breast and prostate as well. So a lot of these programs are now looking at advanced or metastatic diseases. Unlike in ICGC 25K, those projects were primarily focused on primary diseases. So if you look at the breakdown, there are 52% of the projects are planning to do whole genome sequencing along with whole transcriptome. And the programs are into 3 main categories. There's clinical sequencing, there's clinical trial and also discovery research projects. So this brings in much more flavor than ICGC 25K, which were primarily discovery research projects. So that definitely gives us more data, but also more different requirements when making mutation calls. As you can imagine, for clinical sequencing, mutation calls that we made would need to have a much higher confidence than mutation calls that we make for research projects. So that will definitely take into account in our analysis. 60% of these programs have already started or they're existing, and then the remainder one are new and in development. And this is important because we want to get the data coming in early, and it typically takes a bit of ramp up for all the projects. The tumor distribution, most programs are doing multiple tumor types. To be in an ARGO project, there is a minimum of 500 donors that we're requesting. So if a program can contribute 500 donors at a minimum, then they are considered associate members. And if they can contribute 2,000 donors at a minimum, then they're considered full associate members. So as you can see, this is distributed across metastatic tumors. Some programs are doing both primary and metastatic, and some are just focusing on primary diseases. So the progress to date, there are, you can see that in 2018, there are only 7 programs committing. We're now up to 25, and you can see 26 because there's new programs that just came in recently. Basically, we're following this path and making good progress. And so as you see here, ICGC-ARGO has a new structure for governance. So there's the executive board and the management committee that is advised by an independent advisory committee and also the data access compliance office. And then there are the ICGC-ARGO working groups. And so as you see, there are a number of working groups here. And I would just make a call out here, and you don't have to be in a participating program contributing data to ARGO to be part of these working groups. So if there's any working groups that you think that you can contribute, you want to participate in, do reach out to the Secretariat. So there is the Governance Executive Board. And the Independent Advisory Committee is actually still looking for expertise in different areas. And then this is our management committee that meets to discuss the day-to-day operations of ARGO. Okay, so what is OICR's contribution to ARGO? We have a rich history, of course, in leading the ICGC effort. So for ARGO, Lincoln and I are both members on the management committee. And Lincoln is also the lead of the Data Coordination and Management Working Group. And we have several mathematicians that are actively participating in these sub-working groups. Then these working groups basically maybe do benchmarking of methods and make advice on what analysis methods the Data Coordination Center should use. So there are currently 4 active sub-working groups, variant calling, RNA-seq, germline variants, and mutation of signatures. So again, if you're interested in participating, do let us know. And OICR is also leading the Data Coordination Center, and then we have one program contributing pancreatic data, and that's led by Steve Gallinger and Julie Wilson. So here's the ARGO data management infrastructure. We are going to collect over 100,000 donors, and having to do uniform analysis, that's going to take a lot of compute. So there's no one center that can just do it all because of the storage and the compute requirements, and also because some jurisdiction requires that the germline data stays within their country. So that's why we have this model where the programs will submit the sequencing data to regional data processing centers. So OICR is one of the RDPC. We also have commitment from China, South Korea, and also Spain to operate one of these RDPCs. And these RDPCs will analyze harmonize the molecular data. So these pipelines will be recommended by the working groups, further productionized by the Data Coordination Center. So these RDPCs will run the uniform analysis. And the molecular data, some of it will go to these cloud distribution centers, so they can, for long-term storage. And then some of the variant calls will also go to Data Coordination Center. Now the clinical data, since it's much smaller, will be submitted to the DCC as well. And then this data, along with the mutations, would get indexed and made searchable on the ARGO data platform. So the role of the Data Coordination Center at OICR, we are a team of under 20 people working on this. We are developing the ICGC-ARGO data platform. This enables the submission of clinical data and molecular data. We're also doing data curation and also building out the platform for data distribution. We are developing the infrastructure for the RDPC and also operating the RDPC. So eventually what we discover as a blueprint will be given to other RDPC as a blueprint. Then we're also developing the clinical data dictionary with the tissue and clinical working group and also the program stakeholders. I'll talk about that in a minute. And as I said before, we're working on analysis workflows with the working group. Okay, so the clinical data dictionary. This was, we made our first release of 0.3 in February so that our program stakeholders can review. We got a lot of feedback from them and went through iterations. So finally we released version 1.0 in June. So in this version, we have 63 core clinical data fields. What we mean by that is they must have these 63 fields submitted to consider that donor is eligible to participate in ARGO. So this set of data fields have good overlap with M-code, which is important because that is a standard that seems to be getting a wide adoption. And then we're also working on the extended clinical data set. There are about 140 so far. A lot of these data fields are cancer specific. And so the way we do this is we work with the program stakeholders. We got their case report form or their list, maybe sometimes in a spreadsheet, to collate the information they have. So based on the feedback we got, 19 programs confirmed that they will be able to submit all the core clinical fields. We got 4 programs. We had a discussion explaining why they cannot submit some of the core clinical fields, and their explanation is acceptable. So that means in a submission system, we actually have to relax the criteria for them to submit. And then for 3 programs, we have not received feedback. Okay, so I'll just jump into the dictionary so you can see this is live, docs.icgcargo.org. This is a dictionary where you can see multiple versions that are historical in the past. Next up, we're going to have a feature so that you can compare different versions of the dictionary, so it will be easier for folks to figure out what has changed since they last prepared the clinical data. And so in here, you can see there's sort of a table of content for you to easily jump to different sections. So in here, you can basically see that there are fields that are considered core and some that are extended. And then you can also see that some are required and then some are conditional, meaning that this field is only filled in if the previous field here, for example, vital status, if only it is filled with deceased, then the cause of death needs to be filled in. So we try to make it easy for users so that we have ways to filter things out maybe someone is just preparing for the core, then they just look at this. And then we have a set of file templates already. These are CSV files, comma separated files, so that people can it will help them start their preparation of the submission. Okay, so jumping to the next part. Then of course, we are now with the platform ready. We're able to allow people to submit the data. And they're actually, like I said before, there are two separate sets of data to submit. So what we ask people to do first is to register their samples. That includes registering their donor IDs, the sample IDs. This is a really important step because based on our previous experience, we've seen people mixing up their samples or maybe assigning a sample to two donors. This is a mistake that is very costly to fix downstream, because once we start the processing of the data, then it's going to be very complicated. And that's why we go through this registration of samples first. We do a very rigid validation. And then people can start submitting molecular data and clinical data. These two steps can be done asynchronously because we expect clinical data to be submitted by maybe a clinical data curator. In our case, for example, for our pancreatic data, the curator is over at UHN. And then the molecular data may be submitted by bioinformaticians. In our case, is the genome sequencing informatics team. So they don't have to coordinate too much once the sample registration is done. So they can, in both cases, there's a lot of validation on the data to make sure that we good quality of data, because always garbage in, garbage out, and we don't want that. So once we do have the core clinical data submitted for any donor, and we have the the genome raw data, raw sequencing data from a donor with both tumor and normal, then we will kick off the alignment and variant calls. So in ARGO, we have a tiered access policy. So in order to give the programs some protection to prepare to do the analysis and prepare the manuscripts, program members have private access to the data for the first 12 months. And then after the first 12 months, full members get access. And then after another 6 months, associate members get access. And finally, after another 6 months, the data is available for general access. Now, of course, at any point, the data owners can lift the embargo early because they may say their publication is already out. So in June, we released our we made a first release of our data platform. Now, this allows users to do a number of things. For the programs themselves, they can now manage their own members. So they can create users to become administrator for their program, data submitter, or collaborator. Because what that means is any of these members will have access to the program data during embargo. Now, data access compliance, DACO, is still required for downloading control tier data. As I said, the system allows the sample registration to avoid mix-up. The clinical data submission is also ready, and so we have beta tested with 3 programs. We also have some dashboards for the programs to track the submission and the analysis of the data. We have done some semi-automated orchestration of the alignment and Sanger variant calling. So we've released the data for 177 donors. These donors were repurposed from ICGC 25K based on their commitment to provide the additional clinical data. And now we have the documentation site for the dictionary viewer, and also a lot of instructions on how to submit data. And then we also got a contact page for handling different types of inquiries. So I'll just go very quickly to the data platform. This is our home page pointing to a lot of instructions on how to apply for access, how to download the data, information about our workflows. as you're just a researcher, if you're not a part of a member of a program, then you don't need to log in. If you're a part of a program submitting data, then you do need to log in. That's the part that I won't show here because that's probably doesn't apply to many of the people on this call. But what you can use though is the file repository. You can see that we have released 177 donors from 2 programs. This is the pancreatic cancer from OICR, and this is also the esophageal cancer from UK. So this is where you can use the facet to filter down some of the data, and then you'll be able to download both the alignment in the CRAM format or the variant calls in VCF format. So this will be useful for most researchers on this call. Okay. So we expect different roles from our users. So I just wanted to talk briefly on what you get from the platform depending on your role. So for our program stakeholders, we're ready to accept submission of data. They can easily review the data dictionary to prepare the data. And when they're ready, they can just start submitting and give us feedback. They can contact us easily. And then we're still working on this platform. So remember, this is a 10-year project. So there are lots of features to develop over time. We're gonna have more complex validation exception added to the submission system. We'll continue to expand our dashboards. And then the submission of genomic data will open later this year. Probably sometime in the fall, we'll make a call out to our programs to submit molecular data as a beta testing. But the instructions on how to prepare the sequencing data is already available on our doc site. So anyone interested will be welcome to do beta testing. For any researchers like yourself, like I said, we have 177 donors available now, but we're constantly still processing more data. So actually right now, with the release version 1, the donors were from pancreatic and esophageal. But as of today, we have processed almost another 180 donors to bring it up to 353, adding from projects like thyroid cancer and lung cancer as well. And now we also have whole exome data. So you can browse the data in the file repository, and you can download the data using a command line tool. This does require a DACO. And then we'll continue to analyze more data from ICGC 25K. We expect to have about at least 1,000 donors from 25K who have committed already, and we're constantly reaching out to get more. We'll try to get some clinical data into the file repository for searches as well. And then we want to support the download of small files directly from the file browser without using a command line tool. For RDPC stakeholders, I know there are not a lot of people on this call who play this role, but if anyone is interested in running pipelines and interested in our infrastructure, do come and talk to our team because we have done some R&D work to arrive at our infrastructure to run pipelines. Just very briefly, we used Mixflow as the workflow execution engine, and then we use Kubernetes for deploying. So these logos are technologies that you may not be familiar with, but one thing I would stress is that we are following the GA4GH standards as much as we can to be interoperable with other centers as well. What's coming for the RDPC, we're going to do more development work to get it fully automated. Right now, we do need to manually create batches of work, but once that batch is kicked off, it is pretty hands-free for a couple of weeks until the run is done. Then we'll kick off another batch. So we're aiming to get full automation to not even having to do this kind of manual kickoff. We are working on additional analysis workflows, UTech 2. We're also working on creating annotation, such as from Nomad as well. And then we're aiming to have a blueprint of this RDPC so that other centers can set up as well. There are a lot of behind-the-scenes activities for this launch of the data platform of the RDPC, because there are actually a lot of infrastructure to set up. So we were very quick in terms of developing a minimal viable product. This is end-to-end so that we can accept clinical molecular data, we can do the analysis, and then we can make the data available. Now we're adding more bells and whistles to it. We definitely need to harden the platform that we've already developed. That means doing performance testing and tuning. We do need to put in measures against bad actors, because we've seen from other projects, some people may just go really hardcore to do a lot of queries, do a lot of downloads. That can take down the system, so we'll have to prevent that. We do have to put in logging of access to comply with GDPR in Europe. And then we're going to put in web analytics as well to help us improve our system over time and doing a more automated improvement. So because I said before, we do a tiered access, our next big feature is to manage this kind of tiered access automatically. And this is something that involves a lot of design on the architecture side. So this is our team. Like everybody, we've been working just through Zoom, but still collaborating really well. And I think the fact that we could release our data platform as planned in June was a testament of such really great teamwork, even on Zoom. And I do want to give thanks to Research IT, because setting up a lot of the infrastructure involved their help as well. So questions from anybody?